Today, we're going to talk about how artificial intelligence and how my company is working with Google to help power global food production. My name is Craig Gansel, and I'm the founder and CEO of a company called Camp 3 out of Atlanta, Georgia. And we have a product called Farmwave. Artificial intelligence can play a huge role in important industries such as global food production, just to name a few. If I were to ask you, what is this? You would tell me it's an apple. But what if I said, now prove it to me? Prove to me that this is an apple. How do you know that? Because when we were kids, preschool or kindergarten, we all saw the same thing, the little flashcard with the picture, and it said apple. What about that? That's an apple too. But it doesn't look like that. So what do you mean it's an apple? What about that one? That looks different too. Or that. These are all apples. But in global food production, using artificial intelligence, we have to prove it. And not only would we have to prove it that it is an apple, but all the pathogen, pest, and weed infestations that it could infect any crop out there. Welcome to the challenges of AI in plant pathology and agriculture. It's a daunting task to use things like image recognition to identify pathogen and pest infestation in crops or plants, tomatoes, citrus, row crops, anything early on. But this is one of the most critical stages in growing food. If we can identify pathogen pest infestation early enough, that means we could spray less chemicals. That means we have less crop destruction, bigger crop yields. That could mean more food. This is an industry that is really important globally because we all need to eat. Dr. Fei-Fei Li has said it best, build a new data set. And so at Farmwave, that's what we set out to do. We have searched all around the world, universities, large stakeholder corporations, farmers, smallholders, to capture imagery and build a data set that is curated and cataloged for image recognition, for plant pathology, and reducing crop loss. Farmwave is an app that connects people in agriculture with their farm and technology and each other. It's more than just the artificial intelligence, but that's the real powerhouse behind it. In the past couple years that we've been developing Farmwave, we've done pilots and proof of concepts around the world with large corporations such as Monsanto, Syngenta, Bayer, small farmers from India, France, the United States, all around the world, and found out that if we could get Farmwave into the hands of farmers all around the world, we have a really good shot at reducing crop destruction by 20 to 30%. One of the components is communities, enabling farmers to talk to each other. Today, they use things like Twitter and Instagram, but in their day-to-day job and how fast they move and all the tasks that have to happen on the farm, they're using Twitter and Instagram, but all the noise of the news and everything else they follow is kind of getting stuck in the middle. Not to mention, you have some growers who grow for large stakeholder companies where they're doing plant trials, and that information is proprietary and shouldn't be out on the public web. Farmwave gives them a closed-loop community where researchers, agronomists, and farmers alike can collaborate by building field reports in near real time. This allows us to have the data right in the palm of their hands. There's a lot happening in agriculture today. You know, all around the world, there's different companies that are making attempts at autonomous vehicles. John Deere's been doing it for a very long time. We've had autonomous tractors for decades. They move a lot slower, and there's nobody in their way, but they've been doing it for a while. Unmanned aerial vehicles, satellite imagery, hyperspectral color imagery, all of this data is very important to agriculture. And there are many, many companies around the world trying to make an impact into how we could better make use of all of this data to make better decisions in our farming. Howard Buffett wrote the book, 40 Chances. If you think about it, a farmer has in their lifetime an average of 40 chances to get it right. And that's it. Because everything that they do, their day-to-day, is very seasonal. Everything plants in the spring, they harvest and get the results in the fall. Whatever didn't work, they can try it again next year. A farmer in Indiana, Chris Tom of Tom Farms, they farm about 45,000 acres. They're one of the largest growers in the United States. He said something to me once. Don't add more technology on top of existing technology for the sake of adding new technology. So we're trying to train things from the ground up with Farmwave and our artificial intelligence to work with the devices that they're already carrying around with them, or that they're already using today, such as unmanned aerial vehicles, and even some of the machinery. We leverage a lot of technologies within Google Cloud platform. Recently, we've been one of the alpha companies working with AutoML. And we have a partnership with the University of Georgia Agriculture Extension, which is where we are from, Atlanta, where we had what is called the Consortium for Internet Imagery Database System. Owned by University of Georgia, and about 19 other universities around the world have participated in, it is 20 years of imagery data on over 35,000 plant species. So we've worked closely with the University of Georgia, and we got a copy of this database, and we started classifying and labeling and tagging and running imagery through Farmwave. It's been very, very challenging. 19, 18 years ago, we didn't have the kind of mobile phones that we have today, so the pictures really aren't usable. They're not of very good quality. But as we started to see more recent imagery, we have better quality. Some are good pictures, some are not. In plant pathology, you have to get up really, really close and get a really good picture of a leaf to get really early detection, where you'll have an impact that you could identify a pathogen or a pest, make a recommendation and a treatment, and put the input in the field. We also got early on into counting sequences. Today, farmers will help predict yield by counting the kernels on an ear of corn. They do that with a Sharpie. Now, I don't know how many of you have spent time farming, but if you are in the South Georgia heat in July with a Sharpie and you're trying to count kernels on an ear of corn, it's awful. And by the time you roll it around, some of the sweat in your hands washed off the marker, and you don't really have a good accurate count. So using some of the Vision API technology, we've developed a system that allows you to take a picture of the ear of corn, rotate it 180 degrees, take another picture, and it counts it in about 2 seconds. We've been 95+% accurate on these counts consecutively, indoors, outdoors, regardless of different light levels. This is an increase by 17 to 20% of what was acceptable according to the Iowa Corn Board. Later this year, we're going to be launching what's in the middle image, which is called stand counts. Stand counts allow farmers to know how many they have in a given row. Sometimes this imagery can be taken by UAVs, sometimes it's taken on the ground. Cluster counts in tomatoes, wine grapes, helping to predict yield. The more decisions that farmers can make earlier on, the better it is for overall global food production. The image recognition for us was about time. Now let me give you an idea of what it would start like. Here's how it's typically done today. A farmer goes out into the field, or satellite takes a picture, or a drone takes a picture, and they see that there's a distress in an area of the field. Then they'll send somebody out and they'll take a picture. Maybe the farmer knows what it is, maybe they don't. Because even today, we still see new diseases that pop up. So they say, okay, I don't really know what this is. I've got to get this to an agronomist. But I live out in the middle of nowhere in Iowa, in a sea of corn. The nearest university is 4 hours away. So I make a phone call to my local agronomist. He's 2 states away. He'll get to me maybe next week. So he reaches out to the university. They say, we can get somebody to come out and take a look in a couple of days. So they come out, they take a look. If they know what it is, they make a recommendation, they write a prescription, and the farmer calls their dealer, and they come out and put down either an herbicide, fungicide, pesticide, whatever it might be. If they don't know what it is, they have to do some further research. Maybe that takes a couple more days, maybe another week. Depending on climate, weather, traits, whatever they may have, this could spread This could spread from 5% of their crop to 20 to 30 to 40, decimating their yield, losing food. For us, it's about time. Farmwave and the image recognition capability makes this happen in a matter of seconds. Now, 35,000 species from the University of Georgia, 20 years of crop imagery, we are just getting started. This is a huge database. Corn alone and all the diseases in corn has taken us several years just to kind of get under our belt. Because, if you remember the pictures from the apples, we have to look at a crop in all of its different stages, and every disease for that crop in all of its different stages, from early on to 20% severe, 60% severe, fully decimated, to get accurate results. Our library of imagery is one of the only one we know of today and that we have been told that has been properly validated by PhD-level pathologists and entomologists from around the world. But we have to have high accuracy. So we have to have that, but it takes more time. When farmers go out to a field, if you've been through farmland, you'll see these placards. It tells us what kind of crop is being planted right there. In this case, it's a Pioneer version. Using the Google Vision API, farmers are able to very quickly fill out their field report by simply taking a picture, extracting the information from the placard, and putting it into the field report. Then they continue that field report when they get out of their vehicle and they go into the field to actually look at a pathogen or pest problem. This saves a lot of time. Maybe it's just a few minutes a day for a farmer, but that compounds for farmers around the world every year. This sort of information is critical. It has to be filed with state, regulatory, and local county reports. So this information is important to get right. The Google Vision API has helped us tremendously in extracting this information very quickly when going to the field. This is a little bit of a look at a field report inside Farmwave. We help them by recognizing the pathogens and pests, but we leverage everything in Google Cloud where Farmwave lives to get information in near real time. We also geotag where they are. It's very important. When they go out to a field, what has happened in this field? We tag weather, what the weather was, where they are, time, and date. The future of Farmwave next year is to launch an app store in 2019 that allows other machinery and data points from all within agriculture to connect to Farmwave so we can correlate that data and collaborate better. That means if a farmer goes back out to a field and opens up Farmwave to take a field report, it sees where they are. And it says, let me pull your John Deere planter because I know where you are, and I will tell you in a few seconds what was planted in this field, on what date, what seed, what variety, at what spacing, at what compaction. And then let me pull your irrigation sensor data, and I will tell you how much water this crop has had from the day it's gone into the ground till this very moment, based off exactly where you're standing. It pushes those results, it puts them in the field report. Then you can take pictures, notes, video, dictation, and save it. And when you save it, in those communities I mentioned earlier, it gets shared right away with your agronomists, researchers, growers, dealers, anywhere in the world in near real time. A few years ago, I had the pleasure of visiting with President Emmanuel Macron of France. France is the capital of the world in wine and cheese, and it was fantastic to see how they grow differently in France than they do here in the United States. And I've been to Amman, Jordan, and Beirut, Lebanon, and how they grow differently there than they do in France, than they do in the United States. France is one of those countries that GMOs are prohibited, so they have different styles. But data is still as important. And farmers all around France work together through subsidies from the government for new technology every year. We've been visiting with France the past couple years several times, working with different co-ops, growers, and even with the government on how Farmwave could potentially be the single platform that the country uses to aggregate data and do predictive modeling in the future. Because as we look at AI and as we look at machine learning and deep learning and what we can leverage Google Cloud Platform to do, it's about those 40 chances that Howard Buffett talked about. It's about what can we do and learn in for the future based off the knowledge that we get today. I just had a conversation recently with a lady, Dr. Susan Wainwright Evans. She's a world-renowned entomologist, bug lady. She said, I'm pretty skeptical about Farmwave, Craig. I come from decades of experience, and that experience in what I do in the field, we call biases in AI. And she's absolutely right. There's a lot of biases. There's a lot of things that entomologists will just see and do just as their nature from being an entomologist for years that are going to be really hard for us to train in the system. And we're working very hard on that. But the fact is, Dr. Susan Wainwright Evans will not be here forever. And today, it's not very popular to be the next bug lady, so we don't have as many entomologists. In 2017 alone, Dr. Evans spent 3 weeks at home. The rest was on the road. She is extremely sought after in other countries where they see pest infestations that they don't even know what it is, and they need her help to save crops. So, working with somebody like Dr. Evans to help train our machines, to help train our AI to know what we're looking at in pathogen or pest infestation is critical. To preserve her knowledge of the past couple of decades for the future of agriculture tomorrow, so we can better make decisions. These are some of the partners that we work with. Obviously, I talked about the University of Georgia. We did some early work with Google X. Farmwave actually began on Google Glass. I was an early adopter of Google Glass. I went up to New York. I was asked to come up there and get a pair of Google Glass. And a few months after I got it, I went to a John Deere developer conference in Des Moines, Iowa. And John Deere had invited their developers from all around the world to come in for this conference. And it was kind of a, what do you have that's new for us? And the developers were sort of looking at John Deere saying, well, what do you have that's new for us? This one gentleman came up to me and he said, Craig, would you get up and talk about Google Glass and what it's doing? Because a lot of people have asked us about it and what it is. I said, sure. At this point in time, Farmwave wasn't even born yet. We had just gotten up and talked about Glass and what it was doing out of the box. And this was with the Explorer edition. And then as I learned a little bit more about critical problem solving in agriculture, and we learned about the operation of a crop scout to identify these things, I knew that we could use image recognition technology to make these problems go away and make these decisions faster. So it actually began on Google Glass. We did a pilot with Monsanto in 2015 on about 25 different pairs of Google Glass in Illinois, where farmers were able to go out to the field and simply use their voice and take pictures, and it would identify, or they would have the hands-free option because of Glass to hold it up and count the kernels in a matter of seconds. And so that's some of the work that we did early on with Google X. It still does work today on Glass, and actually, yesterday, we launched Farmwave globally in the iOS and Android app stores. I was at an ag tech conference in Atlanta yesterday, and we did our global launch, and we've got 80 countries and about 34,000 people in the past 60 days who have signed up to early adopt Farmwave. It's a critical problem. We are expected by 2050, for the amount of people that will be on the planet, we have to grow more food in the next 30 years than we have in the last 8,000, with less resources, less land, and more mouths to feed. Technology is going to play a pivotal role in making this happen, and we're really glad to be part of that. And we've not been able to do it without the powerful resources of Google Cloud. Within the image recognition that you see on this report 01, you'll see that there's a map at the bottom. I also wanted to point out that the geospatial capability, when you take a field report to show where you are, that populates on a map. Now, if I'm in Iowa and I'm growing corn and I see that I have a problem, and I'm in one of these communities with the Iowa Corn Growers Association, and I take a picture and I do a field report and I alert my neighboring farmers, they'll see where a disease is actually spreading in near real time. And through a dashboard view, if you are an administrator of your Farmwave community or your Farmwave group, you can actually see all of the growers, and through different tags and different tagging on the map, you can actually see it grow and spread in real time. This has an alert effect that can alert other farmers of what's happening and what's coming their way. And it allows in that community for those farmers to communicate with others around the world for advice. A dairy farmer in Wisconsin who farms about 860 cows a day, 3 times a day, is pretty advanced in what he's doing. But a dairy farmer in India who only has 8 cows doesn't have the knowledge or the resources or the skill set that the gentleman in Wisconsin does. Through Farmwave, he can send pictures and ask advice, and because those pictures are in a field report that is location and weather tagged, the farmer in Wisconsin can immediately advise the farmer in India, I see that you have 8 cows, you live in a very humid climate, here's the conditions that you're dealing with, that's very likely mastitis, and here's what you need to do about it. And that's critical to farmers in other parts of the world in growing countries where those 8 cows is the sustainability of their family.